All right, let's talk about something we do all the time without even thinking about it. Breathing. We're going to follow the incredible 5-second journey a single breath takes through one of the most amazing pieces of engineering in your entire body, the respiratory system. It's a trip you take thousands of times a day, and you probably never give it a second thought.
No, seriously, right now. Just take a deep breath in and let it out. Simple, right? No, seriously, right now. Just take a deep breath in and let it out. Simple, right? Well, you do that about 20,000 times a day, completely on autopilot.
But have you ever really wondered what's going on during that journey? Because in just those few seconds, your body is pulling off a whole series of super complex, life-sustaining jobs. So let's do it. Let's follow that breath step by step and see exactly what's happening under the hood.
Okay, so before our breath actually starts its trip, we kind of need to know its purpose, right? Like, what's the end goal here? Well, it turns out every single breath you take is on four, count 'em, four critical missions.
First, the one we all know, bringing in that precious oxygen. Second, its opposite, getting rid of the waste product, carbon dioxide. But then there are two other jobs that are just as vital, but we don't really think about them. It helps keep the delicate chemical balance of your blood just right, and it literally provides the power for your voice. So the big takeaway? This system is doing so much more than just moving air in and out.
So our journey kicks off in what's called the upper airway. You can think of this as the system's prep zone. Before that outside air can hit your delicate lungs, it's got to be filtered, warmed up, and basically made ready for the main event. First up, the air comes in through your nose, and right away it's getting warmed and humidified by all the blood vessels in there, and filtered by tiny hairs and mucus. From there, it travels down the pharynx, that's your throat, which is kind of like a shared highway for both air and food. And then, finally, it hits the larynx, or your voice box. This is where a really clever little flap called the epiglottis makes sure that air goes down the right pipe and your lunch goes down the other.
But here's where it gets really cool. There's this incredible defense mechanism working 24/7. Lining these airways is something called the ciliary escalator. Just picture a microscopic cleaning crew. It's made of these tiny little hairs, called cilia, and they're beating more than 1,000 times a minute. They're constantly sweeping this blanket of sticky mucus upwards, trapping all the dust and germs, and just moving it all up and out of your lungs. It's amazing. And this is why smoking is so incredibly damaging. It literally paralyzes that cleaning crew. It just stops those cilia in their tracks. So your lungs' self-cleaning service, it's shut down. And that allows all those toxins and tar to just build up. It's a direct assault on one of your body's most important lines of defense.
Okay, so once the air is all prepped and ready, it heads down into the lower airway. Now, this is where the system turns into this massive delivery network. The whole point is to get that clean, warm air deep, deep into the lungs.
So, the air flows down your trachea, your windpipe, which is held open by these C-shaped rings of cartilage so it doesn't collapse. Then the trachea splits into two main branches, and these are called the bronchi. One goes to each lung. And here's a little fun fact for you. The right bronchus is a bit wider and straighter than the left one. And because of that, if you ever accidentally inhale something small, it's statistically more likely to end up in your right lung. Weird, right?
Now these bronchi, they just keep splitting and splitting into smaller and smaller tubes called bronchioles. And they create this incredible, intricate structure. It's actually called the bronchial tree. And when you see a diagram of it, you totally get why. It looks just like an upside-down tree. It's this perfectly designed distribution system for getting air to millions and millions of tiny destinations.
And that brings us to the final destination on our journey. The air has reached the very end of the line, tiny little sacs called the alveoli. This, right here, is where the real mission of breathing is finally accomplished.
We are talking about millions of these tiny grape-like air sacs in your lungs. And get this, if you could somehow take them all out and flatten them, their total surface area would be about the size of a tennis court, all packed inside your chest. This absolutely massive area is the whole secret to making gas exchange happen so quickly and efficiently.
And right here is where the main event goes down, what we call the Great Exchange. The walls of these little alveoli are unbelievably thin. We're talking just one single cell thick. This allows oxygen from the air you just breathed in to pass right through into the tiny blood vessels wrapped around them. And at the exact same time, the carbon dioxide waste from your blood passes out into the alveoli so you can breathe it out. It is a perfect, seamless swap.
So you might be wondering, how do these tiny, delicate, wet sacs not just collapse and stick together every time you breathe out? Well, the answer is this amazing substance called surfactant. It's basically a fluid that coats the inside of the alveoli, and it acts kind of like detergent. It breaks up the surface tension, which keeps the air sacs from collapsing on themselves. And this is actually why very premature babies can have trouble breathing. They haven't had time to produce enough surfactant yet, so their little air sacs struggle to stay open.
All right, so mission accomplished, right? Oxygen is in, CO2 is out. But hey, remember those other jobs we mentioned at the start? Let's take a quick look at the system's other, kind of hidden, but just as important roles.
Believe it or not, your body uses your breathing to fine-tune the pH balance of your blood. It's like a thermostat for your blood chemistry. See, carbon dioxide makes your blood more acidic. So if your blood starts to get a little too acidic, your brain automatically tells you to breathe faster to blow off more CO2. If it gets too alkaline, you breathe slower to hold on to a bit more CO2. It's this really elegant, super fast balancing act that's happening all the time.
And of course, speech. That very same air you're exhaling is what you use to communicate. As that air comes back up and passes through your larynx, it makes your vocal cords vibrate, creating sound. Then your tongue, your lips, and your teeth shape that raw sound into the words you're hearing right now. Literally, every single word you speak starts out as a simple breath.
So there you have it. We've followed a single breath all the way from the outside world deep into your bloodstream. And it all happens in just a few seconds. Let's just quickly run through that entire pathway one last time to lock it in.
Okay, so it all starts in the nose for prep work. Then it moves through the pharynx and larynx, down the trachea, or the windpipe, it branches out through the bronchi, arrives at the alveoli for that great exchange, and boom, the oxygen is in the bloodstream, ready to be delivered to every single cell in your body. What an incredible journey, and it's one you repeat thousands and thousands of times every day.
You know, the most amazing part of all this? Your body does it perfectly, about 20,000 times a day, on complete autopilot. You don't have to think about any of it. It really makes you wonder, doesn't it? What other hidden, incredible marvels are busy keeping you alive right this very second?